Alright, so 3-4, your job is going to be to prove that lines are parallel. You cannot assume that lines are parallel just because the picture looks like they are. So you're going to use some various things, angle relationships being one of them, to prove that the lines are parallel. If I can find two corresponding angles that are congruent, doesn't it stand to reason that the lines would have to be parallel? If I can prove that those corresponding angles are congruent, they'd have to be parallel. Now some of you, on the quiz that we took yesterday, you had this picture, right? And then let's say I had an angle number 1 here and an angle number 2 there. What's the relationship between those two angles?
Supplementary.
No, no, they're not consecutive, they're corresponding. Isn't 1 in the upper right position here? Isn't 2 in the upper right position here? No, see, this is what I want to remind you. Remember in 3-1 when we learned the relationships, I didn't tell you that these two lines that were cut by the transversal, I told you that they didn't have to be parallel. We didn't even talk about whether the angles were congruent or not in 3-1. You just identify the relationship. These are still corresponding angles, but because the lines that are cut by that transversal are not parallel, they're not congruent. The relationship still holds true, but they're not congruent because these lines are not parallel. Now, if I were looking at this angle and this angle, 2 and 3, and if I told you that these lines were parallel, they're still 2 and 3 are corresponding, but now those are congruent because they're on parallel lines. So all the angle relationships hold true whether or not the lines are parallel. However, if they're congruent, then the lines are parallel. Or if you have consecutive interior angles and they're supplementary, then the lines are parallel. So I could ask you the same thing. Isn't angle 1 and 4, aren't they consecutive interior angles? Are they going to be supplementary? Are the lines parallel? No. So they're not going to be supplementary. So that there's still consecutive interior, but that congruency or that supplementariness, so to speak, doesn't hold true unless the lines are parallel. So I wanted to straighten that out with you, that relationship still exists, but it goes a step further and is special if the lines are parallel. So, first postulate. Postulate 3-4 says, if two lines in a plane are cut by a transversal so that corresponding angles are congruent, then we can prove that the lines are parallel. Now you had a postulate just like this previously, but it said that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. So it said the same thing, but it said the converse. So this is the converse of that. So this time we're using our knowledge that if corresponding angles are congruent, then the lines are going to be parallel. Now you might want to put a picture next to this if you're still having trouble with your angle relationships. Put a picture next to it that looks like this. Here's your parallel lines cut by a transversal. These would be corresponding angles, 1 and 2. So if you had two corresponding angles that are congruent, we could conclude that the other two lines are parallel. Postulate 3-5 actually has a name. Remember, I don't want you memorizing postulate and theorem numbers, but if it has a name, you can actually put the parallel postulate in there. This one's slightly different. If there is a line and a point not on the line, then there exists exactly one line through the point that is parallel to the given line. So write it down and we'll talk about it. You're going to draw a picture, and it'll make a lot more sense when we draw the picture. Alright, so for this one, it says if there is a line and a point not on the line. So draw a line. And draw a point anywhere but not on that line. So I'm going to draw a point right here and call it P. Isn't that what it says that we have? A line and a point not on that line. Then it says that there exists exactly one line through this point that would be parallel to this line. Wouldn't you agree with that? Isn't there only one line that I could draw through this point right here that would be parallel to this line here? That's all that it says. There's no other way to draw that line through that point except for that way for them to be parallel. All right, next. Says exactly the same as the first one. If two lines in a plane are cut by a transversal so that a pair of alternate exterior angles are congruent, then the lines are parallel. So far we've had corresponding angles. Now we have alternate exterior angles. Now you might want to draw a picture along with this if you are forgetting the angle relationships. There's your parallel lines cut by a transversal. Alternate exterior angles would look like 1 and 2 would be here. There's an example. Then theorem 3-6. Now we have consecutive interior angles. Two lines in a plane are cut by a transversal so that the pair of consecutive interior angles, but consecutive interior angles are not congruent on parallel lines. They're what? Supplementary. And so draw your picture to go along with that. Your consecutive interior angles would be on the same side of the transversal, but inside the parallel lines. The last one that well, it's not quite the last one, but this last one of the angle relationships would be alternate interior. So two lines in a plane are cut by a transversal so that a pair of alternate interior angles is congruent, then the lines are parallel. Alternate interior angles would look like this. They're both inside the parallel lines, but they're on opposite or alternate sides of the transversal. So you're really having to learn any new theorems at all? Aren't they all exactly the same as the previous theorems that you've had? So my point to you is this: if you learn your theorems forwards and backwards, in other words, learn the conditional and its converse, you don't have to double learn them because you already know them. You just use them in reverse. All right, the last one, which is interesting, says, in a plane, If two lines are perpendicular to the same line, then they are parallel. This is just like that one that we said. If the transversal is perpendicular to one line that is parallel to another, then it is perpendicular to the other line. So this is exactly the same thing, but in reverse. It says that if two lines are perpendicular to one, well, then they must be parallel. It's not quite the converse, but it's saying the same thing in reverse. And here's your picture for that one. Here's your two lines. If they're perpendicular to the same line, doesn't it look like that? And the reason why I can prove that those lines are parallel is if these are perpendicular, we've got 4 right angles here, 4 right angles here. What kind of angle relationship do these two have right here? They're corresponding. And if corresponding angles are congruent because they're both 90 degrees, what do you know about the lines? They're parallel based upon what we looked at previously. All right, any questions on those theorems and postulates? Are you okay with those? All right, now we're going to use any of these plus any definitions we've had regarding anything, you know, supplementary angles, complementary angles, linear pair, vertical angles, any of those definitions, plus any of your properties of equality, transitive, substitution, addition, subtraction, multiplication, division, reflexive, symmetric, all of those properties could come into play. Flip it over. You're going to do a proof. Oh boy. Oh boy, I can't wait. So you are sitting next to somebody on purpose. The 3 of you on the side over there, you're going to work together. So Jake, Mackenzie, Brayden, you guys are working together. You are going to work with, I had somebody was missing. You moved, didn't you? Where's your normal seat? Nathan's, oh, Nathan's out of there, okay. You are gonna work with the 2 in front of you. Because everybody else has a partner, right? Okay. Or you can work with Mackenzie and you 2 can work together, I don't care. Alright, but here's what I want you to do. Turn it over, you got your proof on the back, right? I want you to add line, don't talk right now. Add lines L and M here because it's not on your paper and you need that. Your job, you're going to prove theorem 3-5. That means that you cannot use theorem 3-5 in your proof. If you're trying to prove that theorem, you can't use it in your proof. Okay? Look at what you're given. Angle 1 is congruent to angle 2. I know that those lines look parallel, but you cannot assume that they're parallel at what we're trying to prove. Right? So you can't just say that they're parallel because they are. Well, no, I drew them so they looked parallel, but they might be off a smidge. What you can know, proof positive 100%, is that angle 1 is congruent to angle 2. So I would put arc marks on your proof paper to show that that's what the given said. Alright? And I've given you all the statements over here. I want you, and I'm going to give you about 5 minutes where I want you with your partner to figure out what these reasons are. So I'm going to turn the lights on and give you about 5 minutes to work together. And so if you're watching this movie at home, do it on your own. 5 minutes.
Really bright.
Okay, so you're working with your partner. Let's go. I want 100% of you to get the first reason correct. Yeah.
But
Jacob, are you guys working just
Those are corresponding.
That's what we're trying to do.
Not a definition of parallelizing. So think about it.
What?
You just can't use it. It's right next to the question. Put definitions, postulates there, equality.
Okay. Can you do a definition of parallel? You can use anything. Oh, would that work? What?
No. I don't know what that is. Yeah, you have to make it relevant. But there's shorthand notation. All right, everybody look up here. Hopefully you hit the lights again, please. Okay, so let's talk about your proof and your reasons, because you're starting to have a lot of information in your toolbox that you can use, but you don't know quite what to do with it yet. And remember that this is a geometric court of law, and yes, it's very particular. So if you are too brief or too short-winded, let's put it that way, you're probably not putting in enough information. Reason number one, 100% of you should be saying what? Given. Nobody should get that wrong. Absolutely none of you should get that wrong at this point. If you got that wrong, you haven't been listening. All right, so that's number one's given. Then does number two follow from number one, or is it something completely different? It's different. There's nothing from the fact that these two are equal that tells me that those two are equal. What kind of angles are 2 and 3? So if all you put here was vertical angles, that's not enough. I'll say whoop-de-doo. What's important about vertical angles? Because this has a congruence marker here, you need to use the word congruence. I will also accept definition of vertical angles. Okay? So you either have to say, I prefer this because it's clear and specific. But if you said definition of vertical angles, the definition of vertical angles say that they're congruent, doesn't it? That's acceptable. And so is this. Vertical angles, you have to have that congruent symbol in there. So to avoid writing a lot, because a lot of you have been signed, oh, you mean I have to write all that? Yes, but you can use your shorthand notation to shorten it up. So notice I used an angle marker instead of the word angle. So shorten it up. So long as you're using proper notation, I'm fine with it. But you can't invent your own. Don't invent your own. All right, then, number 3 is the one that most of you are going to get wrong. Tell me what your options are, what you thought it should be. Jake Barney. He says transitive property. Trace, right? Trace said transitive property also. What else? A lot of you said, because angle 1 and 3 are corresponding angles, you said what? Corresponding angles are congruent. How do we know that, though? You can't go because they look like it. The postulate says that corresponding angles are congruent on parallel lines. Do we know that the lines are parallel? You can't use it then.
Wait, how do you not know that the lines are parallel?
Pardon?
How do you not know that the lines are parallel?
Because that's what we're trying to prove. Kat said, how do we know that the lines aren't parallel? I know that they're not yet because I haven't proven it yet. Nobody has told me that yet, and so we can't use that. But that's what a lot of you put, right? Corresponding angles are congruent, and if you actually put that, you would have had to say corresponding angles are congruent on parallel lines. Well, we don't know that they're parallel, so scratch that one out. You can't use it yet. Now we have the transitive property. Does it follow the transitive property? For some of you, did you put substitution? Remember, they're closely related. Look at the pattern. Does it follow the pattern? A equals B. Is this B? Equals C? Yeah, so far. Is this A equals C? Doesn't it follow the transitive property pattern? So what are you going to put here? The reason why we know that 1 is congruent to 3 is because of the transitive property here. If these two are congruent because they were given, and these two are congruent because they're vertical angles, they're both equal to the same thing, right? Shouldn't they be equal to each other? By the transitive property of congruent angles. You can't just say transitive property, and it's not the transitive property of equality because we're not looking at an algebraic expression here. We are looking at angle segments. And remember, if you look at that equality property sheet that I gave you, it was split into segment congruence and angle congruence. Since we're talking about angles, it's of congruent angles, but I used shorthand notation. Now the last one says, now that I've proven that these two are congruent, these two are corresponding angles, now you can say, since corresponding angles are congruent, and actually you really have to put in there the whole proof. Look at the first proof on the back, or the first postulate on the back. Doesn't say if two lines are cut by a transversal and corresponding angles are congruent, then what can we conclude? Now we can conclude that the lines are parallel. But look at how you have to write it. I wrote the whole thing, but I used my geometry shorthand notation. Remember I told you that this symbol right here meant if two lines are cut by a transversal? Look at all those words that I cut out there by using that little symbol. So if two lines are cut by a transversal and corresponding angles are congruent, because that's what 1 and 3 are, then I can conclude that those two lines are parallel. The two things had to be present. One thing, I had to have two lines cut by a transversal. The second thing, I had to show that corresponding angles were congruent. Not because they're on parallel lines, but because of the transitive property. So now I can identify them, yes, they're corresponding. Because I also proved that they're congruent, the lines are parallel. Lauren, question?
I put like angle 1 through like parallel lines, which means
No, because angle 1 and 3 are not parallel lines. They're corresponding angles. And we don't know for sure that these are parallel lines, only because we don't see them meet. If they're off just a smidgy bit, somewhere future off, right or left, they could meet eventually. But I now know that they're not going to because I've proved that corresponding angles are congruent. So your job on these is to prove one of those angle relationships true before you say the lines are congruent or the lines are parallel. So either find alternate interior angles, alternate exterior angles, corresponding angles, find those ones that are congruent. If you prove that vertical angles are congruent, does that mean lines are parallel? No. So that doesn't work here. You could also prove that consecutive interior angles are not congruent, but what? Leaf? Head up. Thank you. Or what? Okay, hang on. You could also prove that consecutive interior angles are supplementary. So if you can prove that they add up to 180, then you can prove the lines are parallel. Question?
Doesn't like the given tell us if the alternate interior angles are the same? Doesn't that tell us if they're parallel?
Yes.
So do we have to do all that?
Only because I gave you all the statements first.
But you can just like,
And technically, we can't do a proof off of the given. I know. Odd but true.
so you have to.
I totally concede that point to you. But because you weren't coming up with the statements yourself, he wants to know why couldn't we go, and I don't disagree with him, why couldn't we go from the fact that 1 and 2, aren't they alternate exterior angles? And he said, well, if they're alternate exterior angles and they're congruent, why couldn't I just put right here, if two lines are cut by a transversal and alternate exterior angles are congruent, then the lines are parallel. You actually would put this as a given, and then the next line down, you could cut all this out and put that in there and have a two-step proof. I mean, technically, yes. But we wanted to put a little bit more meat into it rather than use one of those others. It was an exercise. All right, then, here's what I want you to do. Open up your workbook. I want to explain a couple of types of problems to you that you're going to get. Where is my workbook? Oh, there it is. All right, so open it up to 3-4. In addition to doing proofs, some fairly simple proofs, you're also going to be given problems like these where you have to find the value of x so that the lines are parallel. Essentially, you're going to kind of assume the lines are parallel in order to find the value for x. In other words, let's look at 1 through 4. You're going to use your angle relationships. I don't want to see heads on desks. It drives me nuts. You do that in college, your professors are going to kick you out of class, so quit doing it. It's rude. So find your angle relationships. Not all the angles that are given up here have a relationship. So if you identify that the angles have a relationship, you're going to ask yourself, if the lines were parallel, would they be congruent to each other, or would they add up to 180? So on your workbook, I want you to write the following. Look at number 1. We're actually only going to, I'm only going to do with you number 3, but we're going to set up 1 through 4. So look at number 1. Look at the angles that they've given you. Do these angles have a relationship?
Yeah.
What kind are they? Corresponding. If the lines are parallel, L and M, what would those angles be to each other? Equal. So wouldn't you set 3x plus 20 equal to 2x plus 40? And you'd solve, right? I'm not going to ask you to solve it right now. Go to number 2. Look at these two angles. What's their relationship? Alternate interior. What do you know about alternate interior angles if these lines were parallel? Equal or supplementary? Alternate interior. Are equal, aren't they equal? Consecutive interior or supplementary. So we want to set these equal to each other. 4x minus 10 is equal to 2x plus 20. So remember, this was alternate interior. They would be equal. These were corresponding. Look at number 4. Do these have a relationship? Same side of the transversal. Consecutive interior. What do you know about consecutive interior? Those are supplementary. So you're going to add them together. and set them equal to 180. Solve. Now, that's number 4. Now look at number 3. This is why I'm doing this one with you. Does 2x and 3x plus 40 have a relationship?
Yeah.
They do? They don't. They don't have a relationship. You're assuming they're supplementary because you see an acute angle and obtuse angle, right? But why? What can I do to prove it? What could I use to prove that? Jake? Okay, to which? Yeah, 2x in this angle here would be alternate exterior, right? Or the 3x plus 40 and up here would be alternate exterior. Choose one of them, and don't you know that alternate exterior angles are equal? So he's saying, isn't that one also 2x down here? What do these two angles here form? A straight line, which is called a linear pair, right? Don't we add them together and set them equal to 180? So put a plus in here and set them equal to 180. Now solve. Hold everything. I'm running out of juice. I have to plug in. So you solve while I'm plugging in. No, just number 3. Life is good again. All right. So you should have gotten 5x plus 40 equals 180. Subtract 40. And I'm going to work up here because I'm running out of room. 5x is equal to 140. When you divide it by 5, what did you get? You did indeed get 28. So if the lines were parallel, x would have to be 28. No, because they didn't ask what the angle measures were. If they did, then you would. He wanted to know would you put them back in the angle. Only if they asked you for the angle measure. We used our knowledge that alternate exterior angles would be congruent on parallel lines, so we're kind of assuming that they're parallel. And that if they were parallel, that would be equal. Those form a linear pair. That means they'd add up to 180. If x were 28, then the lines would be parallel. So for the lines to be parallel, x would have to be 28. Yes? Yeah, 3x and 2x are on the same side. Does that make sense? You're collecting like terms. All right, any other questions on that? Okay.